All right, geometry, here we go. 8.4. This is probably one of my favorite lessons in geometry. Just because I get into trigonometry and I think it's super fun, but hopefully you find it the same. Here we go. We've been talking a lot about the relationships between, especially on a right triangle where we have something that is like a side, like an angle that is locked in. How if we extended the side length of something, it affects the angle opposite, right? So, I drew that picture before where we had like a right angle. It looks like this, right? So this might be the original. And then if I extended this length, I'll extend it way out to exaggerate it. Okay. We know that this angle and this angle is the same, but if I extended, and you could say this is the same as this, right? That's about the same. But if I extend this side length out, notice what it did to this angle. This angle got tiny compared to this one, right? And this one actually got, this one here in green got way bigger than this one. Okay, so there's a relationship between the opposite side, okay, the sides of a triangle and the opposite angle. Okay, and this whole idea of trigonometry was built on this relationship. So, trig ratios. Ratios of the lengths of two sides of a right triangle. That is important that we're talking about a right triangle right now. That's the only kind of triangle in which this works. There's some special things we can do with non-right triangles, which we'll learn later, but for now we're just looking for right triangles. So what I want you to memorize, if you haven't done so already in an earlier class, is I want you to memorize this this little saying, SOHCAHTOA. SOHCAHTOA, what that represents is the S in SO represents the sine. Okay, sine is always equal to an opposite side over the hypotenuse in a right triangle. So if I have a right triangle here, let's say that I'm looking at this angle right here. Okay, if that's my perspective, excuse me. The opposite side would be this one, and the hypotenuse is always across from the 90, which is this guy right here. Okay, the cosine, C for cosine is the adjacent side over the hypotenuse. Okay, so for adjacent to, if I'm looking at that same perspective, adjacent would be this guy. Adjacent means next to. And then hypotenuse is always the one straight across from the 90. So some people get confused here and they think that the hypotenuse is adjacent. You will never confuse it if you remember the hypotenuse is always straight across from 90, no matter what. Okay, and then the tangent, if you're looking at that from that same perspective of this theta right here, the tangent is the opposite over the adjacent. Okay, so from this perspective, this would be opposite, this would be adjacent, this would be the hypotenuse. Okay, so that's SOHCAHTOA. Make sure you memorize that. You're going to want to have that memorized and because you're going to use that a ton. So here we go, the trig ratios. This is simply what I just told you. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so you can read through that and get some more examples there, but those are just the ratios I just talked about. So let's look at an example here. If you were looking at the sine of A, so if you're looking at sine of A, I draw this thing here, this is a theta. Sine of A, that means from the A perspective, if you were sitting here at angle A and you were looking out, the opposite of you would be 3, and then the hypotenuse is always straight across from the 90, which would be 5. So the sine of theta, the sine of A, would be 3/5, which is listed here. The cosine from that perspective would be the adjacent. Okay, so the adjacent is, let me just write this here. This would be adjacent to A. This would be opposite to A. This would be the hypotenuse no matter what. So the cosine would be the 4, the adjacent over hypotenuse. So you get the 4/5. Tangent is opposite over adjacent, which would be 3 over 4. And then what they do, once you think you're comfortable with that, is they say, okay, now let's look at the perspective from B. Okay, so now if you said the sine of b, the perspective from b, your perspective changes. Now the opposite is 4, right? So you get 4 over 5. And then the cosine from b, this would be the adjacent to b, right? And this would be the opposite to b. So the cosine of b would be 3/5. And then the tangent would be the opposite over adjacent, which would be 4/3. Okay, so there's an example. So here we go. Let's try this out. Here's number 1, example 1. It says find the sine of C. Okay, so this is your perspective. From there, your opposite is 8, and your hypotenuse straight across from the 90 is 17. Okay, so we have 8/17. Your sine of B, okay, so if you're looking at B now, from there, your opposite is 15. So we have 15 over 17. All right, and then we go to cosine of C. Cosine of C is, again, this perspective, which would be adjacent, which is 15, over hypotenuse, which is 17. And the cosine of B, if you were at this perspective, would be 8 over 17. So notice the cosine of B is equal to the sine of C. That's kind of interesting. And the sine of B is equal to the cosine of C. And then for tangent, so the tangent of C, that means we're starting right here, opposite is 8, adjacent is 15. So we have 8/15. Then the tangent of B would be 15, opposite over adjacent, which is 8. Okay, so that's how you do number 1. Then it says use special right triangles to find trig ratios. It says use a special right triangle, which we learned last time, to express the cosine of 45 degrees as a fraction and as a decimal to the nearest hundredth. Draw and label a 45, 45, 90. Label legs with length x and the hypotenuse with x root 2. Step 2, solve for x. All right, this is kind of confusing unless you're actually going to get in there and do it. So we'll come back to this using your special right triangles for number 2. So don't worry, we'll get back to that. But here we go. This is interesting. What does my sine button do on my calculator? It gives you the proportion of the opposite length over the hypotenuse at a given angle. So if you punch in the sine of 40 into your calculator, it'll give you 0.64, blah, 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 blah. This is the proportion of the opposite side over the hypotenuse whenever the angle is 40 degrees. Okay, so if this is 90, and I said this is 40, okay, what this 0.642786 says is whatever my opposite side is over my hypotenuse on this triangle, that relationship, the O over the H, has to equal 0.64278676, blah, 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 blah. Okay, so I can use this ratio and this idea to solve lots of any kind of right triangle that I need to, as long as I know a couple of pieces of information. So for 3a, it says, find a missing side using trig functions. All right, so we're looking for this. Okay, I know this angle. I could also find this angle very easily, but since this is given to me, I'm going to use the 25 degrees. So this is my perspective, right? This is my theta. I'm looking for the opposite of that angle, and I happen to know the adjacent of that angle. This is the hypotenuse, and I would recommend, when you're first learning this, to always draw this out, like draw out where the hypotenuse is. From this perspective, this would be the opposite, this would be the adjacent. Okay, so if I'm looking for opposite and I know my adjacent, I'm going to use these two pieces. Well, if I'm using those two pieces, the trig function that deals with opposite and adjacent is the tangent. So I can say the tangent of 25 degrees is equal to opposite, which is x, over adjacent, which is 18. Okay, to solve this for x, I can multiply both sides by 18 here, and I get x is equal to 18 tangent 25 degrees. Simply put that into your calculator, and what you'll end up with is approximately 8.39. Okay, so that's how you can solve these using trig, which is pretty cool because we haven't done that up until now. For 3b, it says start at 70 degrees. Okay, we're looking for x. X is the, hopefully you can name that as the hypotenuse. From 70 degrees, this is my adjacent. Okay, so which trig function deals with adjacent and hypotenuse? That would be the cosine. So I could say the cosine of 70 degrees is equal to adjacent, which is 15, over hypotenuse, which is x. Okay. To get x by itself here, be careful. Don't just multiply both sides by 15. The x is in the denominator. So if I want to get rid of x on both sides, I have to multiply both sides by x, right? So when I do that, I get 15 is equal to x times cosine of 70. Then I need to divide both sides by cosine 70 to get x by itself. All right, so I get x is equal to 15 over cosine of 70. The other thing you can do once you do that enough, you'll see that these two things just switch whenever that happens. Okay, so they switched places there. And if you end up doing that on your calculators, let's just go ahead and do it. Take 15 and divide it by the cosine of 70 degrees. So if we do that on our calculator here, where's my calculator? Sorry, guys. Well, I'll let you do it. I don't even know where my calculator app is at the moment. You guys are probably looking at it, laughing at me. That's funny. But anyway, on your calculator, just take 15 and divide it by the cosine of 70 degrees. That's so weird. I don't know where it's at. And anyway, whatever you get for that answer, that'll be the correct answer. As long as you're in degrees, make sure you're in degree mode on your calculator. Make sure you're not in radian mode, and you'll get the right answer for that one. And by the way, to approximate that, you know that that's the hypotenuse that you're searching for, so you'll know that it'll definitely be bigger than 15. Okay, so when you do that, you should be getting something bigger than 15. Now, that's the end of the first part of this lesson, okay? The second part of the lesson is all about finding the angles. This is called inverse trig ratios, okay? So it's used to find the angles of something. For instance, if I have, on 4a, I'll make this quick, if I know these two pieces, and I'm trying to find, say, this angle A, how can I find that? Well, from this perspective, I know the opposite and I know the adjacent. So I know that the tangent of A is equal to 6 over 20. Okay? Now, I'm looking for A. To get A by itself here, this is a weird new thing that you have to get used to. But we're not multiplying tangent by A. That's not what we're doing. This is a trig function. So to undo the tangent, what you have to do is you have to use the tan inverse. This is also called the arctan, or arcsine, arccosine. And to do that on your calculator, you'll see a button that looks like this, like a tan to the -1. That is what undoes the tangent function. So if you want to get A by itself, you have to actually take the tan inverse of both sides. So now we know that A is equal to the tan inverse of 6 over 20. Inverse functions always gives you angles. So whenever you're looking for an angle, you're going to use an inverse trig function. Okay. So here I went through some of the numbers that you can use to try this out. And also a little reminder, make sure your calculators are set to degree mode, not radian mode. And if you need help with that, hopefully somebody in class can help you with that, or I can help you with that. Here is 4b. So 4b is, I think we're looking for, I don't know what we're exactly looking for here. They might want us to find all pieces of this, so let's try to figure this out. So here, if I was looking for, looks like we're doing A here. Okay, from A's perspective, I know my adjacent, which is 3, and I know my hypotenuse, which is 15, so that's a cosine. So I know that the cosine of A is equal to 3 over 15. From what we just talked about, I can take the cosine inverse of the cosine of both sides, cosine of A, cosine inverse of 3/15, and this crosses off, and I'm left with A is equal to cosine inverse of 3 over 15. If you end up doing that, you end up with 78.5. So if this is 78.5, I now can tell you that this, if you needed to find B, would be 90 minus that, right? Because this is a 90-degree angle. All triangles add up to 180 degrees. So you can subtract that to find that. And then if you wanted to find out what this length is, you can either use trig or you can use your Pythagorean theorem, right? So once you know your angles, you can solve the whole triangle. And you can use any method you're comfortable with. Excuse me. So here it goes. Solve the right triangle. Use what you know about triangles to find the missing measures of the angles and sides of a right triangle. So here we go. 5A. For this one, if they give me this and they say to solve the triangle, what you need to know is you need to find angle F, angle G, and this side length. Okay, to find that, I can use the Pythagorean theorem to find this, all right, or I can start using trig. Okay, so if I want to know what this angle is here, let's start with F. So from F, I know that 5 is opposite, and I know that 13 is the hypotenuse. Okay, so that's sine function. So I could say the sine of F is equal to 5 over 13, which means F is equal to the inverse sine of 5 over 13, which looks to be 22.6 degrees. All right, so if that's 22.6, then what I can do is I can use that idea, and it looks like they want us to round the angle to the nearest degree, but I can use that idea to figure out what G is. Okay, so technically G would be 90 minus 22.6, but if we round to 23, then you'll have a whole number versus a decimal, but either way it doesn't really matter. And then just do what the directions ask you. And then step 3 says find FH using the Pythagorean theorem. Okay, so you can say 5 squared plus FH squared is equal to 13 squared. Remember that the 13 is the hypotenuse, it always has to be over here. All right, so if we do this out, we get FH squared is equal to 169 minus 25. FH then is equal to the square root of, and let me just do this out here. So we have 169 minus 25, which is 144. Square root of 144 is a nice number. It is 12. Okay, let's do a couple more here, and then we'll be done with the video. So here we go. 5B. It says find the measure. Basically what they want you to do on example 5 is solve the whole triangle. So if you know that this is 62 and you know this is 90, you can find C very easily. C is just going to be 90 minus 62, which is equal to, in this case, 28 degrees. Okay, so C is 28 degrees. You know this is 10, which is your hypotenuse. Okay, so the hypotenuse is 10. And let's find out what these side lengths are. So what I can do is I can say, okay, if my hypotenuse is 10, I can find I can find side AB very easily. From 28 degrees, that would be opposite over hypotenuse, right? So I can say the sine of 28 equals AB, side AB, over 10. So AB would be equal to 10 times the sine of 28 degrees. So you can go ahead and put that in your calculator and see what you get. And then to find my final piece, I can either use the Pythagorean theorem with my answer from step 2, or I can just use the fact that that's the same thing as cosine. So cosine of 28 degrees would be equal to BC over 10. So BC would be equal to 10 times the cosine of 28. Okay, so whatever that comes out to would be your BC. For 5C, this isn't much different. So if this is 33 degrees here, I know that I can find this. This is going to be 50, what would that be, 57? Because 57 plus 33 equals 90. And then from there, I can use my trig functions, right? So I know if I want to use this angle as my perspective, I know my adjacent to that angle. Okay, so I can look for my opposite and use my tangent function. So I can say the tangent of 57 is equal to QR, which is opposite, over my adjacent, which is 16. Which means QR is equal to 16 times the tangent of 57 degrees. Okay, so you go ahead and put that in your calculator and you can see what QR would be. Once you have those two pieces, you can use the Pythagorean theorem to solve this. So let's just go ahead and or you don't have to do that. You can also use a trig function. So let's do that. So you can put this in your calculator, figure out what that is, solve for QR. For PR, we know that from this that if we use the perspective of 57 again, that the cosine of 57 would have to equal 16, which is adjacent, over the hypotenuse, which is PR. Okay, if we solve for PR here, remember that these two things would just switch places. So we say that PR is equal to 16 divided by the cosine of 57 degrees. Put that into your calculator and you have PR. This should be the longest side because it is the hypotenuse. All right, you guys, that's it. That should give you everything you need for your homework. We'll catch you guys next time.